You know, it's really nice to be here in Korea with all of you. And in fact, the fact that so many of you are here at 8 p.m. on a Friday evening, either in person or watching this on home, is, I think, a tremendous sign of the enthusiasm that there is for AI in Korea. So thank you all for being here or watching this online. And in the last few days visiting Korea, I've been really excited and really grateful to participate and to see the energy and momentum in the software industry here, as well as all the momentum in building AI in academia, as well as in large business, as well as in startups. And so I was thrilled to hear all the great work that NIPER and other government organizations are doing as well. And honestly, I think Korea has a very bright future in AI. What I'd like to do is share with you some opportunities that I see in AI globally as well as in Korea. And I hope that if in the future I can play some role, some small role to support the rise of AI in Korea, I would be thrilled as well. So one of the tricky things to understand about AI is that it is a general purpose technology, meaning that it's not useful just for one thing, it's useful for a lot of different applications. Kind of like electricity. If I were to ask you, what is electricity good for? You know, it's useful for a lot of different things. So AI is the new electricity, and I think it's starting to revolutionize all parts of society and of our economy. I'd like to step through with you how I see the technology landscape, and then this will lead into some, I think, exciting opportunities, maybe for all of us to work on in AI. There's a lot of excitement and hype about AI, and I think a good way to think about AI is as a collection of tools. So one of the tools is supervised learning, which is very good at labeling things or recognizing things. And then another important tool is generative AI. If you work in AI or study AI, you may have heard of other tools as well. But for today's presentation, I won't speak as much about them, but I'll just focus on the two most important, which are supervised learning and generative AI. So supervised learning is very good at labeling things by input to output mapping, so A to B, input A to output B. For example, given an email, you can use supervised learning to label is this spam or not. Or the most lucrative, financially profitable application of this I've worked on, maybe not the most inspiring, but was probably online advertising, where given an ad, we can label if a user is likely to click on it. And today, for a company like Google, this type of technology drives more than $100 billion US a year. For self-driving cars, you can input sensor readings from the car and label the position of the other cars. One of the projects my team at AI Fund did was working on ship route optimization, where we can input the route that a ship is going to take and label that with how much fuel this will consume, and we could use that to optimize fuel consumption. My team did a lot of work with visual defect inspection, so we can take a picture of a smartphone or other manufactured object and label it with whether or not there is a scratch or any other defect. Or if you want to do reputation monitoring of a restaurant, say, you can input a review and output, label that with is this a positive or negative sentiment. So one of the interesting things about supervised learning is it's not useful just for one thing. It's useful for all of these exciting applications and many, many more. Let me walk through the workflow of what building an AI system using supervised learning will look like. If you want to build an AI system to label reviews, you come up with a few data points. So you can say, the student GPA was great, label that as positive sentiment. Or if someone says service is slow, then label that as a negative sentiment. Or my favorite Japchae, positive sentiment. So here I've presented 3 data points. If you're building this in a practical application, you may need a few thousand data points of reviews and labels. And so the workflow of building an AI system using supervised learning would be to first get labeled data like this, with both the input A and the output B. And then you would train an AI model and have it learn from this data. And after that, you might find a cloud service to run or to deploy the model to start making predictions. So now you can say, best downchain GPA I've ever had, and label that as a positive sentiment. And so I think the last decade was the decade of large-scale supervised learning. What we found about 15 years ago, 10, 15 years ago, was that if you built a small AI model, so a small neural network or a small deep learning model, then even as you fed it more and more data, its performance would improve only for a little bit and then flatten out, plateau, and stop improving. And what we found 15 years ago was if you build a very large AI model, then as you feed it more and more data, its performance seems to keep on improving. So when I started and led the Google Brain team, maybe about 10 years ago, the primary mission I set for that team was, let's build really, really large neural networks. And that recipe turned out to work, and the recipe of scaling up data as well as compute power has driven a lot of deep learning or AI progress over the last decade. How about this decade? I think this decade is turning to take supervised learning, but add to our toolbox generative AI. So for text generation, I know many of you will have played with tools like ChatGPT or Bard, but in text generation, you can input a piece of text called a prompt, like I love eating, and if you run it a few times, you can say Gabi or Dosso Bibimbap or Gabi Jam, and that's the AI output. This is an exciting technology, but let me take just half a slide to explain how this technology works. It turns out that at the heart of generative AI is using supervised learning, A to B, input-output, to repeatedly predict the next word. So if the AI reads on the internet a sentence like, my favorite food is gochujang samgyeopsal goreng, then it will turn this into a few data points where one would be, given the phrase, my favorite food is, in this case it should predict the next word is gochujang. Then given, my favorite food is gochujang, the next word is samgyeopsal, and similarly, for the last example, it should predict goreng. And it turns out that if you train a very large AI system on a lot of data, meaning hundreds of billions of words, or in the case of the largest system, 1 trillion or more words, then you get a large language model like ChatGPT. There's some additional technical details. Technically, rather than predicting the next word, you predict something called the next token. There's also a technique called RHF for further refining the outputs to make them more honest, harmless, and hopeful. But at the heart of generative AI is this idea of using very large data sets and repeatedly predicting what is the next word. And so, whereas many of us will be using ChatGPT and Bard as a consumer tool, you can log into the website and use it, and I think it's a fantastic tool. What is less widely appreciated is that prompting is also revolutionizing AI software application development. In particular, there are a lot of AI applications that are now much easier to build because of prompting. So in the traditional supervised learning approach, to build, say, a restaurant review system, you would get labeled data, maybe that'll take a month, get thousands of examples. Then you have engineers to help you train an AI model. That might take 3 months. And then finding a cloud service to run the model, maybe another 3 months to get it running robustly. So it's maybe 6 to 12 months would be a pretty realistic timeline for developing and deploying a valuable commercial grade AI system. Teams that I had led, very good engineers, we often took 6 to 12 months to build these systems, and feels like a long time, although some of the systems we built turned out to be very valuable. But with prompt-based AI, it turns out the development cycle can be much faster. So the workflow with prompt-based AI is you can specify a prompt, so write a piece of text. This can take minutes, maybe hours, and then to deploy the model to start making inferences might take hours or maybe days. And so I know you were probably not expecting me to write code in this presentation, but I'm actually going to do that. And it turns out this is all the code I need in order to build and deploy a sentiment classifier. So let's see. Not to hold the mic while doing this. Okay. So I'm going to load and import some tools from OpenAI, and then I'm going to write a prompt. Classify the text below, delimited by 3 dashes as having either a positive or negative sentiment. So let me just write some text. And then I'm going to take the prompt and send it via API. I've actually never sent this particular phrase. Okay, thank goodness you got it right. And so in about, 20 seconds, I built and used a sentiment classifier. And so today, and this is literally all the code that someone needs to write today to build a sentiment classifier. So what this means is that there are many applications that used to take me 6 to 12 months to build and deploy that many people can now build in maybe a few days or maybe in a week. And this also means that we can try out a lot more ideas, prototype much more quickly, and just ship a lot more AI products. So I think that many people today still don't fully appreciate the huge wave of AI applications that I think can be built because it's so much easier and faster now for certain types of applications. So a couple months ago, working with some folks from OpenAI, I actually released a course on using ChatGPT as a developer tool. The course was ChatGPT prompt engineering for developers. And in about 2 weeks, we had 500,000 enrollments, making this, as far as I know, the fastest course in the history of online education. And I think this is a sign of the number of developers that are learning about these tools and are starting to build many exciting applications. Also, earlier this week, when I was at Seoul National University, we announced that we're working to take a lot of materials we have on these short courses to provide Korean language translation of the subtitles. So I'm excited about, hopefully working to provide more of these materials to the career development community as well. So in light of the technology landscape with supervised learning and generative AI, let me share a bit what I think of as some of the exciting AI opportunities. So the sizes of these circles show what I think is the value from different AI technologies today. Supervised learning, which can be worth more than $100 billion to a single company, has massive value today. And there are also millions of developers working to build supervised learning applications. So it has massive momentum and will continue to grow. Generative AI is much newer. Fewer of the use cases have been worked out yet, but there are also a lot of excitement on this, and so this is also going to grow rapidly, I think. And again, just to complete this, those are some of the technologies that I'll spend less time talking about. But if the sizes of the circles are the value of these technologies today, this is what I think it will grow to in 3 years. The value of supervised learning, because of the millions of developers working on it, I think might double in the next 3 years. So go from really massive to even more massive. And generative AI, while smaller now, will much more than double in the next 3 years. And 3 years is a very short time, so if this rate of growth continues for another 3 years, then 6 years out, the value from these generative AI will even compound and be much larger. But the opportunities are, all of this light green and light orange shaded regions, that's where there are opportunities for either startups or large incumbent companies, or for academia to create and to realize value. But one thing about all of these technologies is they are general purpose technologies, meaning that they're useful for many different tasks. So a lot of the work that lies ahead of us is still to identify and execute on the concrete use cases of these technologies. So massive value remains to be created using supervised learning. And even though we've not yet finished finding all the useful things we could do with supervised learning, we have this new tool, generative AI, that even further expands the set of things we could do using AI. But there's one caveat, which is that there will be short-term fans along the way. I'm not sure how many of you remember the app called Lensa. This is an app that would let you upload pictures of yourself, and then it would draw a really cool picture of you as a scientist or an astronaut or something. And so it was a very popular app, and its revenue took off like that really quickly through last December, and then it did that. And I think this is because Lensa was a good idea, people liked it, but it was also a very thin software layer, a very simple software layer, built on top of someone else's very powerful API. So even though it was a good idea, it didn't last that long as a very high value business. When I think about what happened with Lensa and this as a thin layer on generative AI, I'm reminded of what happened when Steve Jobs gave us the iPhone. With this platform technology change with the iPhone, there were also fads. For example, someone figured out how to turn on, I should see this, figured out how to turn on the LED to turn the phone into a flashlight. And that was a good idea. I mean, I paid $199 for that. But that was another fad because it was a thin software layer built on a very powerful AI platform that did not really stand the test of time. But when we got the iPhone, when we got smartphones, someone also figured out how to build Airbnb and Uber and Tinder. Those really hard, really deep businesses that stood the test of time and create long-term value. And the thing that excites me about AI is with this new generation of AI technologies, with these new AI platforms, I think there's an opportunity for us to figure out how to build the really hard, really deep businesses that can create long-term value for everyone. So this is the first trend I want to share with you, which is generative AI as a general purpose technology creates a lot of new opportunities for startups and for incumbents and for others. There's a second trend I want to share with you, which addresses why isn't AI more widely adopted yet. So a lot of us have been talking about AI for 15 years or something, but today a lot of the value is still concentrated in the consumer software internet companies like Google, Microsoft, Meta, Naver, Kakao. So why is that? So if you were to take all current and potential AI projects and sort them in decreasing order of value, you get a curve that looks like this, where to the left of the curve are projects like online advertising, where you can hire, say at Google, hire 100 highly skilled machine learning engineers to build an ad system and apply that system to 1 billion users and generate massive financial returns. But it turns out that once you go outside consumer software internet, where this recipe works really well, we built many valuable projects in consumer internet, but once you go outside consumer software internet, hardly anyone has 100 million or 1 billion users that you can build one AI system and apply to. Instead, in other industries like food manufacturing, these are some of the projects I've been excited about. We're working with a factory that makes pizzas, and they need to do things like take a picture of the pizza to make sure that the cheese is evenly spread. And so this is a $5 million problem, but the old recipe that my friends and I have worked out of hiring a lot of very highly skilled engineers to work on one application, that doesn't work for a $5 million application. This is another example. We're working with an agriculture company, and together with them, we figured out that if you can use cameras to figure out how tall a stalk of wheat is, then you can chop up the wheat at the right height. You get more food out of the farm for the farmer to sell, and it's also better for the environment. But this is another $5 million project that the old recipe of hiring 100 engineers does not work for. And many other examples like this, materials grading, cloth, sheet metal grading, and so on and so forth. So whereas to the left, in the head of this distribution, there are a few billion-dollar projects that we know how to solve and that works and that's valuable. Here, in this long tail, I see tens of thousands of $5 million projects that people have a hard time executing on. Because of the huge number of applications in this tail, I think the aggregate value in the tail may be even greater than the value in the head of this curve, but the challenge is how do we unlock this value? So the second trend I want to mention that I find exciting is the AI community has been working and is developing much better tools to make it easier to build these applications. So specifically, no-code and low-code tools are starting to enable the user to let them customize their own AI system. So for example, if we have tools that let the IT department of the pizza maker train their own AI on pictures of the pizza to build their own custom AI system, then the IT department of the pizza factory can realize this value by themselves, and same for the IT department of the agriculture company. The technology to do this is we can now increasingly let users provide prompts or provide data using a technology called data-centric AI, instead of having to ask them to write very advanced AI code. And this is opening up the set of AI applications that can be economically built. And I think this is important because this, I think, is a key to unlocking the value in AI, not just in consumer software internet, where it's working quite well, but to take the value of AI and take it to really all industries, including non-consumer software internet. So given these two trends, AI as a general purpose technology with a lot of exciting opportunities we can build, as well as these technologies, tools that are helping us to push AI outside consumer software internet to all other industries, what can we do? A puzzle that I wanted to solve about 5 years ago was I felt that many valuable AI projects are starting to be possible. And this is even much more true now than 5 years ago when I was thinking about this. And the puzzle I wanted to solve was how do we get all of these many projects done? And even though I had led AI teams in big tech companies like Google and Baidu, I couldn't I couldn't picture myself able to operate a team in one big tech company to go after such a large diversity of applications in everything from maritime shipping to financial services to healthcare to education and on and on and on. So about 5 years ago, I decided that starting many new companies is an efficient way to do this, which is why I started AI Fund as a venture studio to partner with entrepreneurs to build multiple new companies in order to pursue different meaningful projects. And in fact, with my visit to Korea and seeing the buzz and excitement here, one of the things I'm excited about exploring the future is to see if we can work together to maybe build something here in Korea as well. So speaking of partners, to explore if we can do that. And then of course, in addition to starting new companies, I think incumbent companies also have many opportunities to integrate AI into existing businesses. So many incumbent companies have significant distribution power, and that too could be a huge advantage for building and shipping AI products. But just to be concrete, where are these opportunities? So let me share with you what I think, what is the AI stack and where some of the opportunities lie. At the lowest level of the AI stack is the hardware, semiconductor hardware. I know there's a lot of work in Korea on semiconductor, a lot of exciting work. I find that this sector tends to be very capital intensive and very concentrated, so I don't personally play there myself, but I know given the strong semiconductor industry in Korea, I think it makes sense that a lot of companies here are playing here. Then there's the cloud infrastructure layer, which again tends to be very capital intensive, very concentrated. I think they're good opportunities, but again, I don't play there myself, not much. And then there's the developer tools. In the coding demo that I showed just now, I was using OpenAI as a developer tool to build a sentiment classifier. I find that the developer tool sector is hyper competitive. Look at all the startups chasing OpenAI, but there will be some mega winners. Maybe OpenAI will be one of them. And so I tend to play here, but only carefully and when I think my team has a unique technology advantage, because I think that gives you a better shot at being one of the huge winners and providers of developer tools. It's a very competitive space. And then lastly, a lot of the media attention, a lot of the excitement is on the infrastructure and developer tool layer. And it turns out that despite all that attention on this layer, the only way for this layer to be successful is if the application layer is even more successful. Because for infra and tools to be successful, the application layer has to generate even more revenue for them to be able to afford to pay the infrastructure and the tooling layer. And we saw this with the rise of SaaS as well, with the rise of cloud, where a lot of the media attention was on the technology, which is great because the technology is exciting. But the only way for those companies to be successful, tools companies successful, is if the applications built on top of them are even more valuable. And interestingly, when my team works with different partners to build different applications, we find that often there are rich needs, rich user demands, but not nearly as intense a set of competition. So let me illustrate this example. Over the last few days, I was actually texting back and forth with the CEO of Amarai. We're working together on some things. And Amarai is a company that my team AI Fund has been working on that applies AI to romantic relationship coaching. And I just want to point out, as an AI person, I feel like, I know nothing about romance. And if you don't believe me, you can ask my wife. She will confirm that I know nothing about romance. But when we decided to pursue an opportunity in AI applied to romantic relationship coaching, we wound up working with the former CEO of Tinder, her name is Renata Naibor, and with my team providing AI expertise. And Renate, because she ran Tinder, she knows apparently more about relationships than anyone else I know. We're able to work together to build something quite unique, applying AI to romantic relationship, to relationship mentoring. And if you look at how many teams in the world are experts simultaneously in AI and in romantic relationships, there's actually not that many. So even though there's a huge market need for this, I mean, many people want better relationships, the competition set, it just doesn't feel nearly as competitive. And I feel like there are actually a lot of applications that are exciting. So in fact, the last few days in Korea, we're speaking with many different groups in many different industry sectors. And I feel like in Korea, there are many businesses, AI applications that really make more sense to build in Korea than even Silicon Valley. Because, for example, the differences in the Korean ecosystem and the global tech ecosystem means that there are applications in financial services or electronics manufacturing or these other sectors where Korea is strong that would be easier to build a business in Korea than for someone like me in Silicon Valley to do it by myself. But what I want to do is just walk you through our process for building startups. Over the last 5 years, my team has repeatedly refined and honed our process for building startups, and I want to just share with you our recipe for building startups because it just seems to work well. Hopefully this will be interesting and useful to some of you too. But my teams we always had access to a lot of ideas. Right? We talk to people and they share startup ideas with us. Internally, our team has ideas. But I want to walk through this process with one illustrative example of the company Bearing AI, which is a company that uses AI to make ships more fuel efficient. So this idea was suggested to me by a large conglomerate called Mitsui that operates a line of ships, or is a major shareholder in a line of ships. And this is one of those examples that, I would never have had this idea myself because I've been on the boat, but what do I know about global maritime shipping? But Mitsui came to me a few years ago and they said, hey Andrew, you should build a startup to use AI to help ships find better routes and make them more fuel efficient. A large ship today may use $450,000 of fuel a year, and it turns out that we can save maybe 10% of the fuel. But when a partner shares an idea like this with us, we then spend about a month validating the idea. So we do a market validation to make sure that it's a useful product with market demand, and do a technical validation to make sure that this is technically feasible. So we actually build a prototype to make sure it's technically feasible. After this validation, we then recruit a CEO to work with us to build this business. In the case of Bearing AI, we recruited a fantastic CEO, Dylan Kyle, who's a multiple-time entrepreneur, who's had one successful financial exit before, and he joined us to build this company with us. In the current process, we then spent 3 months building a technical prototype and doing deep customer validation with the CEO, usually doing actually 6 2-week sprints, so 3 months in total. If the company survives this step, and it has about a 66% survival rate, but it survives this step, if after this still looks good, we then make a larger financial investment into the company to give the resources to grow an executive team, build a real product, hire a team, and then hopefully go out to raise the next round of funding and keep growing from there. And having done this a few times, I've learned that my swim lane, what my team needs to be really good at, is AI technology. And I find that AI technical experience is important for this process because we have to be able to do accurate technical validation, have to make sure that AI tech is done quickly and well. And I think that the businesses we work with will always, I think, manage to help the companies build a strong technical team. And I find that with this recipe of us providing the AI expertise and others coming to work alongside us to take us into industries that we otherwise won't know much about, this is actually a pretty efficient process for building valuable businesses. So today, there are hundreds of ships on the high seas that are about 10% fuel efficient because of this company, and I'm actually quite proud of the work that we're able to support Dylan Kyle as well as Mitsui to accomplish. I want to share just one other tip or one other unusual aspect of startup building, which is that we like to engage only when there's a concrete idea. So kind of where do the ideas come from? And I want to share this with you because this runs opposite, this runs counter to a lot of the standard advice that you hear in design thinking methodology, which is that we like to start work only when a partner shares with us a concrete idea. So for example, these are ideas that are not concrete. If someone comes and says, hey Andrew, you should apply AI to financial services, because I am not a subject matter expert in financial services, I don't know what to do with that. It takes me it take me too long to go and learn enough about financial services to figure out what to do. In contrast, this is a concrete idea. This is not a serious idea. One of my partners wrote this as a joke, kind of tongue-in-cheek. He said, YGP eliminates commercials by automatically buying every product in exchange for not having to see any ads. It's not a good idea, but it is a concrete idea. And we found that concrete ideas can be validated or falsified efficiently. You can quickly decide that this is worth doing. It also gives a clear direction for the team to execute to see if it's workable. And it turns out that there are a lot of subject matter experts in today's world that have often thought deeply about a problem for many months, sometimes even 1 or 2 years, but have not yet had an AI build partner. And we found that when we get together with them and they share their idea with us, often that allows us to validate and build a startup very efficiently. So I think that with this recipe, in fact, in the conversations we've been having over the last few days, we actually heard a few really intriguing, concrete ideas from different career partners. And so I'm going to keep on exploring if it's possible to collaborate with teams here to build something. Before I wrap up, I just want to say a couple words about risk and social impact. And this is my last topic, which is, we take responsible AI seriously. AI is a very powerful technology, and my team, and I think really all of us, I hope will work only on projects that move humanity forward. So specifically, AI Fund, we have killed and we will continue to kill projects that we may even assess to be financially sound, but based on ethical grounds. And this has always been a part of who we are. And to dive a bit deeper into the risks of AI today has problems with bias, fairness, accuracy. I think the technology is improving quickly, so they're becoming less biased, more fair, more accurate. But these are still unsolved problems, and it is important that we continue to pay a lot of attention to these problems. And when I look at problems of risk of AI, I think one major risk is that it will disrupt many occupations. This is a chart from a research paper by one of my friends at the University of Pennsylvania and some folks at OpenAI, showing the exposure of AI to different jobs according to weight. So on the x-axis, the horizontal axis, is the annual salary or the annual wage. On the vertical axis is how exposed the tasks of different jobs are to automation by AI. It turns out that in the earlier waves of automation, it tended to be the lower wage jobs that were more exposed to automation. Like when we put robots in factories, for example. But in this wave of disruption by generative AI, it appears that it's the higher wage jobs that are more exposed to automation by AI. And so I think that even as we build AI technologies and create tremendous value, I think we have an obligation as individuals and citizens and corporations and as society, with government playing a big role too. I think all of us have an obligation to make sure that the people whose livelihoods are disrupted are also well taken care of. And then lastly, this is my last slide. I think there's also been a lot of hype about artificial general intelligence, or AGI. I think that's still decades away, maybe 30 to 50 years, maybe even longer. But the idea of AGI has created a lot of hype, I think much too much hype, about whether AI creates an extinction risk for humanity. Honestly, I don't see AI creating any meaningful extinction risk for humanity, for a few reasons. One, people worry if AI is more powerful than us, well, is there extinction risk? Well, it turns out that we have lots of experience steering very powerful entities, such as corporations and nation states. Corporations and nation states are much more powerful than any single person, but we've managed to get them, for the most part, to benefit humanity. And then second, AI develops gradually, and so the hard takeoff scenario where AI is only working so-so, and then one day suddenly overnight it achieves super intelligence and takes over the world. I mean, technology doesn't develop like that. AI will become more and more intelligent gradually, and develop gradually, which gives us plenty of time to put in place safeguards and oversight to make sure that it is safe. And finally, if you look at the things that are an actual existential risk to humanity, and I think there are a few, such as, fingers crossed, the next pandemic. I know Korea handled the last pandemic really well, but other countries didn't all do as well. Or climate change, which could lead massive parts of the planet to be nearly unlivable, leading to massive depopulation, huge parts of the planet. Or much lower probability, but maybe another asteroid doing to us what it did to the dinosaurs. if you look at the actual real existential risk to humanity, I think having much more artificial intelligence will be a key piece of the solution, and having much more intelligence can only help us safeguard against the things that are an actual real extinction risk. So I think if you want humanity to survive and fly, to survive and do well for the next 1,000 years, rather than trying to slow down AI, I would rather make AI go as fast as possible. And so that, just to summarize, I think AI as a general purpose technology creates a lot of opportunities for all of us to build exciting, meaningful projects. AI is such a huge benefit to society right now, with some risks as well. And the last few days, visiting Korea has been, frankly, my team knows I tend to just work. I'm not known for having fun. But honestly, I really had fun the last few days in Korea. And I hope that in the future, we have more opportunities to engage and work together as well. So with that being said, thank you all very much.
Thank you very much. Thank you. We will have a Q&A after all the sessions conclude. Thank you very much. 네, AI가 가진 기회에 대해서 말씀을 해주셨습니다. Supervised Learning과 The Generative AI 앞으로의 성장 예상 말씀을 해주셨고, 단기 인기가 아니라